Our first question today is to sketch the polynomial that's here. We did this in a three-step process. First step is the roots. So we're going to look here and find our roots. Remember that any x provides a root. So we have an x here, here, there, and there. So that means we should have 4 roots that we're going to get here. So this one, that first one, that x squared, gives us a root at 0, -4, +3, and +5. The second thing is what happens at those roots up there. Okay, well, we look at the multiplicity for those. So we're looking at the exponent here. All of those are 1 since they didn't have anything, but that one there that I circled is a 2. So what is going to happen at the root of 0 with that 2 multiplicity? It's going to bounce or create a little parabola there. What's going to happen at -4? It's going to go straight through. At 3, straight through, and at 5, straight through. And our third step is to figure out the end behavior. We do the end and then the beginning. The end is from the leading coefficient. The leading coefficient here is a -1. Negative means it ends down. Okay, so over on our graph, I am going to go ahead and mark that it ends down. Okay, and the beginning is based on the degree. Okay, to get the degree, we're going to add up all of my multiplicities. So I've got a 2, a 1, a 1, and a 1 from up here. 2, 3, 4, 5 is odd. Odd is opposite. We need to know opposite of what, and that's why we had to have the end first. It ended down, which means it has to start up. So the start of the graph is going to be up. I need to go ahead and get my roots on there. So we had a root at 0, -4, 3, and 5. All right, now I can go ahead and sketch. So I'm going to start with my red arrow. I am first approaching the root at -4, so I look at my notes here and it says that I'm going to go straight through that. So I go straight through. Then I'm going to need to turn around. My next root that I am approaching is 0. What's going to happen at 0? It's going to bounce off, so I bounce right off of that root. I don't go through, I bounced. Then I need to turn around. Remember, we turn around between every root. At 3, I go straight through. I turn around. At 5, I look, I go straight through, and that has me matching my arrow there at the end, so I'm ending downward. Okay, our next question, write the exact equation from this graph. All right, well, in order to write the equation, I need factors, and I am looking for my roots to create those factors. So I have a root at -1, so that means I'm going to have a factor of x plus 1. I have a root at 2, so I'm going to have a factor of x minus 2. And I also have a root at 3, so I'm going to have a factor of x minus 3. And I look at those roots, and at all of them, I go straight through, straight through, straight through. Okay, so none of them have a multiplicity, so I'm not going to add a squared or a cubed or anything on them. The other thing that we need is we have to start, because they are asking us for an equation, we need to have an f of x. And they did ask for an exact equation here. Exact means that I do have to have an a value. And so that's the next thing I need to find. Now I do know that my a is going to be what kind of number? Okay, and that is that this graph ends downward, so I know the a is going to be negative. I cannot just choose any negative number because it did say exact here. So what I have to do in order to find that is I have to plug in another point. So I look on my graph, I need a point that is not an x-intercept, and they gave me one here, 1, -2. And so I am plugging that in. That's going to be my x and y value. Remember that f of x is like y, so we're going to plug -2 in. And then we have a, And then the next factor was x plus 1, but in for x, we're going to plug in 1. In for x, we're plugging in 1. In for x, we're plugging in 1. Okay, 1 plus 1 is 2. 1 minus 2 is negative 1. 1 minus 3 is negative 2. So I'm going to multiply all of those numbers together. 2 times negative 1 is negative 2. Negative 2 times negative 2 is a positive 4. Divide both sides by 4. We get a equals negative 2/4, which reduces to negative 1/2. Okay, so my final answer, f of x equals negative 1/2. Remember, we knew that it was going to be negative, so that is a check for us. The a value did come out to be negative. If it didn't, we would need to look again and see if we made some sort of mistake. All right, there's our final answer. Okay, and our final problem today is kind of a new one. We have not done ones like this before, but now that we know our long division this week, we are going to figure this one out, and then we'll practice them more next week as well. So this is kind of the what we're going for in all of this stuff we learned about polynomials, is being able to do these problems, which is that I am giving you a graph, and I am asking you for the roots of that graph. Now, if I had a picture of it, I would be able to just look at where it crosses, and I would know the roots. But we do not have that here. So we have the roots of, we have one root of this. It says that x plus 5 is a factor. Okay, that means that negative 5 is a root. So I'm going to create a little answer blank for myself here. In order to end this problem, I need to fill in all of the roots here. And I know that negative 5 is already a root that was given to me. Now, how many other roots do I need? For that, I look at my original equation. It is a third degree. What third degree means is that I am going to have 3 roots. So if they gave me 1, how many am I going to find? 2. So what we have to do is what we're going to do is we're going to take that x plus 5 factor and we are going to divide it out of the equation, and that way it leaves us with a polynomial that only has the 2 roots that we need. And so what we need to do is we have to divide our f of x. I'm not going to write the whole thing out because it's hard to write on the iPad. And we are going to divide it by x plus 5. So we're going to take all of this and divide it by x plus 5. And the way that we do that, we learned how to use the generic rectangle in the opposite way. So x plus 5 is here. And we are going to plug in x to the third because that is our first term. The first term was always what we plugged into the first box. Okay, so we have x squared times x is x to the third. So that must be x squared, so this would be 5x squared. Now what I do again is I go back up and I am looking at the x squared terms that I have, and I have negative 19x, or, oh, no, excuse me, let me go back. I do not have any x squareds. Let's put a 0x squared in there. That was a little tricky one there. I almost missed it. We have 0x squareds, and so that means that if I have 5x squared, I need to have negative 5x squared in order to combine these and make 0x squared. Well, if that is there, then now I can get my outside number. This has to be a negative 5x, and that means I have negative 25x. All right, now these 2 boxes of my x terms have to make my negative 19x. So if I have negative 25x, what do I need in order to make negative 19? I need 6x. Let me write that in black. It's hard to see it. There we go. That means this has to be a 6, and that means that this is 30. Now, if I look, 30 matches, which it should, because they told us that x plus 5 is a factor. That means it has to divide equally. So what I have left over is x plus 5 was a factor I knew, and it leaves me with x squared minus 5x plus 6. Okay, this x plus 5 gives me one root, and that is the root that I know, -5. That leaves me with my other two roots in that polynomial. Now, I need to find the roots of that polynomial. That, luckily, we have known how to do for a long time. You can either factor or do the quadratic formula here. So I am not going to show all of that work. I'm just going to show what the factors would be. They would be x minus 2, x minus 3. And you can factor that using the diamond problem and generic rectangle, or you can do the quadratic formula. So if I have that factored, remember I had the one root that I already knew of -5, and now my other two roots that I didn't know are revealed, 2 and 3. And from the very beginning I said that I needed 3 roots, and I have them.